Welcome to the channel Encyclopedia Catanica. In today's video I'm gonna show you what's inside of this padlock. This is very interesting magnetic padlock from Yugoslavia. It's from Republic of Croatia, from town of Pula on Adriatic Sea. This lock is made out of zinc, and the shackle is chromed, made out of soft steel. Here are the keys, magnetic keys, and lock works perfectly. That's practically it. But we're gonna explore what is inside of such padlock. We have one more padlock. This lock was jammed when I bought it. It was very cheap, like this one. Both of those are from probably 1989 or 1990. I'm not sure, but at the end of Yugoslavia. So when I flip it, you see those two are the same. So we have pretty simple but effective mechanism inside. As you see, here is the shackle, here is the counter spring. It's not in like in usual ways where the spring is located here. This spring is located here, and that's a really smart solution. I will explain you why. This bridge is practically a locking pole, and those nails are nails which interact with the magnets on the key. So we have the second set of keys for this lock, and you will see how it works. See those nails? They are moving, they are setting into the correct way. So when you pull the shackle, the mechanism is released and you are able to open it. When you close the shackle, see how the whole mechanism retracts and you won't be able to open the lock. So this mechanism is practically unpickable. Why? Because it's so hard to overcome all those security features. I will show you which of those are implemented in this particular lock. I don't know, for example, Nukstukas lock or surprise lock from Soviet Union, or those South Korean or Asian locks. Many manufacturers made magnetic locks, but in most cases I think all those were less secure than this one. I never opened any other lock except this one because it was jammed. I don't like zinc components. Usually, if they are made of pure zinc, it's okay. They will last long and they will work fine. But if they are made with zinc with some amounts of impurity, it could be a disaster because of zinc rot. When you have impurities such as lead, for example, the zinc component will crack and you will have dust as time goes by, as time passes, and the lock won't work. Something was a problem with this lock, and I had to open it It was really easy because all those walls, you see those walls of the body, rectangular body, all those walls are really thin, and the lock is generally unsecured. This lock is meant to be used for boats, for marine environment, but the whole concept was abandoned from all factories, not just from Tehnomont, but from all factories, because those locks are really easy to smack and whack open. They are really weak in speaking of brute force attack. So we're gonna see what are those components inside. The main components are those two. You see, this is some kind of holder, guiding holder for the nails and for the plate. It's made entirely out of zinc. This plate is made out of copper, pure copper, and it contains those small nails. Those nails, you see them? They are practically hanging from this copper plate, and they all have notches, little grooves, and they are stuck here on the 4 places, and because of that they are constantly moving, and that's how the magnet orientate them to the correct position. So we have this locking pole. This is locking bridge. I could name it locking bridge, because here is the locking pole, and it's connected to this bridge, on which, if you see closely, let me zoom in a bit, we have true gates on the 4 places, and also we have false gates, 6 of the false gates. See how they are orientated in very specific way. So this lock is so hard to pick or to defeat in a non-destructive way. Why? Because you have false gates. You have many of them. One more feature which makes it so hard to do it, to pick this lock, is this actuator. See this actuator here? It's spring-loaded actuator, and because of that, when you pull the shackle, you have this counter spring, which make it retractable when you want to lock it. You don't need to squeeze it, it retracts by a force from this steel spring. But when you want to pull the shackle, the moment when you pull it, see how this lever behaves. So this lever makes this locking pole go, see, it goes immediately on the right side, and it squeezes those nails in some spots. So if you have it stuck on false gate, you won't be able to feel anything if you want to pull the shackle and feel the binding order or something like that. So the shackle is out of the question. What should you do? What could you do? Practically nothing. You need to invent a machine, electrical machine, which will be applied to this notch here with changing current, so maybe you will be able to set by random activating electromagnetic field, you will be able to set it to the correct position, but you have to constantly shake the shackle up and down in order to set all those nails to the correct position. So it's practically really pita job. It's pita job because in every other case it's much easier to do that. In this case it's so hard to do that. I will take it back. It's easy, really easy to assemble the lock. Here we have it, all set in place. Let's see if it does work. It works fine. So, practically this lock is unpickable. In conventional way, you won't be able to pick it. So this concept is really good concept. It's really thought out concept. But the problem is, the main weakness are those plates, those surfaces of the rectangular body, which are so thin. And because of that, they are made out of zinc, and zinc is not good material if it's so thin, the whole concept is abandoned. There are some small factories which make still those magnetic type of locks, but those locks are huge, not so small like this one. This one is tiny lock, it's not big lock. Those make locks like alloy, huge locks. But probably those are so expensive that if they are more expensive than alloy and they are not susceptible for master keying, they are only for private, for commercial entities and not for industrial entities. So those locks have their boundaries, and because of that no one worked on some new implementation or some advanced mechanism from this concept. Everyone just abandoned this concept and they don't care anymore. But it's really thought out. I told you, when I pull the shackle, see? When I pull the shackle, the lever, spring-actuated lever, squeezes the bridge and the nails are blocked. So when you use any kind of moving magnet, you won't be able to do anything if you pull the shackle to feel something. See? Some are free, but this one isn't free. This one is jammed. This one also is jammed. At least two or one of the nails will be jammed, and you won't be able to pick the lock, to feel anything if you put some pressure on the shackle, pulling force. So I hope it was interesting for you guys. I didn't saw a YouTube video about explaining the mechanism and showing it to you. So maybe I'm the first, maybe I'm not the first, I don't know. Anyway, that's it. Thanks for watching. Have a nice day. Bye-bye.